In mathematics, engineering, and manufacturing, a solid of revolution is a solid figure obtained by rotating a plane curve around some straight line that lies on the same plane, assuming that the curve does not cross the axis. The solid's volume is equal to the length of the circle described by the figure's centroid multiplied by the figure's area. A representative disk is a three-dimensional volume element of a solid of revolution. The element is created by rotating a line segment around some axis, so that a cylindrical volume of pi r2w units is enclosed. Finding the volume. Two common methods for finding the volume of a solid of revolution are the disk method and the shell method of integration. To apply these methods, it is easiest to draw the graph in question, identify the area that is to be revolved about the axis of revolution, determine the volume of either a disk-shaped slice of the solid, with thickness delta x, or a cylindrical shell of width delta x, and then find the limiting sum of these volumes as delta x approaches 0, a value which may be found by evaluating a suitable integral. Disk method. The disk method is used when the slice that was drawn is perpendicular to the axis of revolution, i.e., when integrating parallel to the axis of revolution. The volume of the solid formed by rotating the area between the curves of an and the lines and about the x-axis is given by if g equals 0. This reduces to. The method can be visualized by considering a thin horizontal rectangle at y between on top and on the bottom, and revolving it about the y-axis. It forms a ring, without a radius f and in a radius g. The area of a ring is, where r is the outer radius, and r is the inner radius. The volume of each infinitesimal disk is therefore the limit of the Riemann sum of the volumes of the disks between A and B becomes integral. Cylinder method. The cylinder method is used when the slice that was drawn is parallel to the axis of revolution, i.e., when integrating perpendicular to the axis of revolution. The volume of the solid formed by rotating the area between the curves of an and the lines and about the y-axis is given by if g equals 0. This reduces to. The method can be visualized by considering a thin vertical rectangle at x with height, and revolving it about the y-axis. It forms a cylindrical shell. The lateral surface area of a cylinder is, where r is the radius, and h is the height. Summing up all of the surface areas along the interval gives the total volume. Parametric form.